they are more likely to be recommended to benign users by the recommender model. It means that the adversaries have to mimic the benign user's behavior and then update and transfer the embedding of the target users items to the users. That address the challenge one, that is active engagement. How can we do that? So here we have like a paragraph. First of all, for the benign users, it will transfer its gradients, that is the gradients of the item embedding, to the adversaries. And secondly, the adversaries will update its own user embedding locally with the gradients collected from the benign users. Thirdly, the adversary users will freeze its own user embedding and solely update its item embedding to make the target items ranking as high as possible. Later, it will then transfer and distribute the polluted gradients of the item back to the benign users. And because from the benign user side, it doesn't know whether there's malicious users within its neighbors. So normally it will update its own item embeddings in such a way. For example, for the first benign users, the target item is not in the list. After updating, the target items is added to the recommendation list. And for the second benign user, the target item is already in the list. But after updating, the ranking of the target items achieve higher. In this way, adversaries can influence the benign users without actually knowing the benign users embedding. Furthermore, we have the second challenge is the locality impact. So in order to maximize the influence of all the adversaries, so we will use a regularizer to encourage the distinctiveness of different adversaries, make the user embedding of all the adversary users as far as possible. Here we can see UI and UK stands for the user embedding of the adversary I and adversary K. In this way, we can make sure that all the malicious users, they expand all the communities and they have like a maximum possible influence on all users. As for the proposed defense method, the research gap is that unlike the federated recommendation systems, where we have like a central server to aggregate and mitigate the polluted knowledge from the adversaries. In the decentralized recommendation system scenarios, we don't have such a centralized server to do so. So we have the user level clipping with specified updating for defense, which relocating the defense mechanisms from the cloud server to the user level. So we have the user level clipping. It means that for each benign user, it will cut off the largest gradient aggregated from its neighbors, whether it is a benign user or an adversary user. And the second step is the adaptive gradient updating. We will have like a gradient bank for each benign users to store all the gradients transferred from its neighbors. And we only select a small portion of it each epoch to update, which will further decrease the influence of the adversaries. Since the portion of the adversaries is normally small, like 5% or only like 1% of all the users. And for the experiments, we conducted our experiments on the two widely used real-world datasets, MovieLens and the Amazon Digital Music. And we have like 4 research questions. The first one answers the effectiveness of our attack method. And the second research question answers the effectiveness of our defense method. And the third one is for the application study, stating that different parts of our work will contribute to the final process. And for the fourth one, it is the number of adversaries influence the overall performance. And here we can see that for the attack methods, here the exposure ratio for the target item is higher the better. We can see the proposed method will have like a higher exposure ratio with negligible decrease in the overall performance. So normally it will not be detected by any kind of defense mechanism. And for the defense methods, we can see that the hit ratio, the higher the better. But for the exposure ratio, the lower the better, because it is like a defense method. And unlike any other defense mechanisms, they sacrifice the overall performance to achieve the defense. Our defense method will have like the almost similar overall recommendation performance, but can reduce the influence of the attack maximally. And that is all the presentation, and any suggestions and questions are welcome.